Hey everyone, so in this lesson we're going to go over factoring sum and difference of perfect cubes, which is your last type of factoring, so congratulations, you made it, you did it. So the first thing I'm going to do is I'm going to list all the types of factoring you guys have learned, and the last one is going to be factoring the sum and difference of perfect cubes, because that's what we're doing today. So number 1 was GCF, number 2 was dots, number 3 was AM, number 4 is technically grouping, but I'm going to write AC, which is the glasses method that we did yesterday. And number 5 was grouping. And then today is your 6th one, and I'm going to write sum and difference of cubes. Okay? There's another little saying you're going to go with that one in a second, and you'll learn what it is soon. So the first thing that we want to talk about is the do now. And the do now says, given the polynomials, explain what you would do differently to factor these. Well, let's just talk about this, and you would obviously write this out in words. But first off, I notice that they're both trinomials, okay? And the two types of factoring you know for trinomials are AM and the glasses method, which is the AC method. AM can only be used on the first method because, or the first polynomial, because A is equal to 1. And AC can be used on the second one because we have a number in front of the x squared. So I would just explain that in the first trinomial, I would have to use the AM method, which means that I would have to find the factors of 6 that add to -5 and factor. Whereas in the second one, I would have to do the AC method, which means that I'd have to take the first term, multiply, well, the first coefficient, and multiply it by the last one to get -12. Find my factors of -12 that add to -11, and then I would write a polynomial with 4 terms, and then I would group that, and then I would factor by grouping and get my answer. So that's the two different ways you would, that's how you explain how to do that. All right, so what we're going to do is we're going to use something called the reverse box method to explain to you how to factor perfect cubes. Now, the first thing you guys need to know is, what is a perfect cube? Well, for letters, it's x cubed. It's anything you could take a cube root of. So let's have a little mini lesson over here of what a perfect cube is, okay? So perfect cubes is something you can cube root. So let's talk about letters. Letters, clearly x cubed is a perfect cube because x times x times x. X to the 6th, x to the 9th, x to the 12th. If you notice, the exponent is a factor of the 3 times table. It has to basically have an exponent that's divisible by 6 because you need to be able to break it up into 3 variables with the same exponents. And if you notice, this is the only way you can do that because when you multiply exponents, well, when you multiply variables, you add exponents, and this would be the only way for you to have the same exact variable with the same exponent. The other way you can think of it is that you can take the cube root of these guys. If you remember back in Algebra 1, you divide these, and if it's divisible by 3, it's a perfect cube. So for letters, if the exponent is divisible by 3, it's a perfect cube. Okay? Numbers, you just need to be able to take the cube root of it. Okay? Without having no decimals. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125, and so on and so forth. Those are a few of your perfect cubes. And that's how you get your perfect cubes, is just doing them out. So like 6 cubed, you'll get the next one, which I believe is 216. 7 cubed, and so on and so forth. So that's how you would do that. I'm just going to double check on, yep, 216. So let's go ahead and let's start to learn how to factor perfect cubes. So the way I'm going to go over this is by using the reverse box method. You guys are very familiar with the box method. It allows you to multiply binomials, polynomials. So here's the deal. if you notice, we have x cubed plus 1,000. So we're going to think backwards. What would need to be here to get x cubed in this box? You would need x squared. What would need to be here to be 1,000? Well, 10 times what would be 1,000? You could do 1,000 divided by 10, but it would be 100. Okay? Now, if you are aware, there's no middle term. And the reason why is because these guys cancel out. So let's fill in the ones we can fill in. Well, we can fill this one in because we have the side and the top. We can also fill out this one because we have the side and the top. Now, what would cancel them out? Well, negative 10x squared would cancel this diagonal out, and negative 100x would cancel this one out. So what I would need is I would need a negative up here to get that negative, and I would need a 10 because I want to do x times something gets you 10x squared. And I would need another x because I want to get x squared here. I would not need another x at all because this would get you your 100x. Okay? And then that would be the other factor, and this equals that ultimately. And you can see that it multiplies to that because we just did it, but we reversed it. So this is the formula for factoring perfect cubes, okay? Let me just make this bigger. So it's different with the signs. Number one, this has to be a perfect cube and this has to be a perfect cube, the first and the last term. It's different with dots in the fact that you can have subtraction or addition. And the reason why is because you can take a cube root of a negative, because a negative times a negative will come out a negative. So you can multiply 3 negatives and still get a negative. And that is a perfect cube because a perfect cube, again, is something times itself 3 times. So the only thing that's going to be different is the signs. So if you notice, this is originally a negative. Your first would be a negative, and then you get a positive and a positive. The second one is a positive. This is a positive. You'll get a negative and a positive. So there's a few things that you should notice here. This sign is the same as the first one, and the last one's always positive. But the middle sign is opposite of what you started with. So this one started with a negative. The second one is a positive. This one started with a positive. This one here is negative. So the way that I teach it is I use the phrase SOAP, S-O-A-P. And this tells me my signs. Same, opposite. And this one is always positive. Okay? Now, how do you get your terms? Well, I use the phrase square multiplies square. Okay? So you square the first term to get this. You square the last term to get this. And you multiply the two of them to get the middle. So if you notice AX. But you'll get the hang of it once we do a few of these. So, step 1. This is actually the first example we did with the reverse box method. But step 1 would be to take the cube root, and you'd get x plus 10. Now, remember, you're going to get a binomial here and a trinomial here. Okay? So, this is where the word SOAP comes into play. S-O-A-P. It tells you your signs. So, same, check we did that. Opposite would be negative, and always positive would go here. Now, how do you get the other terms? Well, you can think of it logically. If I did x times something, I would need x cubed, and it would have to be x squared. So that's why I always write SMS, because if I times 10 by something to get 1,000, it would have to be 100, and that's squaring 10, so it would be 100 here. And then to get your middle term, middle multiply, 10x, okay? Some people, they like to write in this spot, they like to write 10 squared. But ultimately, you're going to mostly see 100 here. Okay? Okay. First step, take the cube root of the whole thing. X minus, don't freak out, the cube root of 1 is 1, the cube root of 8 is 2. So 1/2. I'm going to write my SOAP, same, opposite, always positive. Again, this is giving you your signs. So same as what you started with. Opposite is positive and always positive. All right. And then square, multiply, square to get these guys. Because x times what will get you x cubed? X squared. 1/2 times what will get you 1/8? 1/4. And then to get your middle term, it's 1/2 x because you multiply them. Now I know that it's a negative 1/2 in this first one, but do not worry about the signs, please. It's the SOAP that takes care of them, okay? So that's your factored form. Next one. Take the cube root. Cube root of y cubed is y, and the cube root of negative 27 is negative 3. Write SOAP, S-O-A-P. Same as that, same sign. Opposite sign, always positive. Okay? Square, multiply, square. Y squared, 3 squared is 9. Multiply to get 3y. Do not worry about the sign. We write SOAP to worry about the sign. Okay? Just make sure I'm not forgetting anything. Okay. Next one. First step, take the cube root of the whole thing. Cube root of a cubed plus b cubed is a plus b. Just because it's letters doesn't mean you can't handle it. You can do this. Then write the word SOAP, same, that checked out. Opposite, always positive. So opposite of positive is negative, always positive, positive. Square, multiply, square. So a squared, b squared, multiply these two to get the middle. I kind of think of it like this. This is the first term, so you square the first term to be the first term. This is the last term, so I square the last term to be the last term. To get my middle term, I just bring those two together with multiplication. Okay, cube root this whole thing. Then I'm going to get x minus 5. Write the word SOAP, S-O-A-P. Again, the SOAP phrase is just telling you same sign, opposite sign, always positive. Then I'm going to square this, square the last one, and multiply to get the middle. Do not worry about the sign, please. SOAP takes care of the signs. If you're not sure, you can always do the reverse box method like we did before. So if you're really not getting this, what you could do is reverse box method. And I will do that right now for some people who want to see it. So you still have to do like the cube root thing to get the side. And then you're going to put in what your polynomial is, which is this, okay? And then you're going to try to figure out the 3 terms up there. So you're going to think to yourself, x times what gets me x cubed? X squared. Negative 5 times what gets me negative 125? That's positive 25. And then these cancel out. So negative 5x squared would have to cancel out with positive 5x squared. So it would have to be here. Well, let's think. X times what gets me 5x squared? That would have to be 5x, positive 5x. So if you see, that's how we get our answer here. This is the first, and then this is the second parenthesis. Okay, first step is to take the cube root, m plus 2. Same, opposite, always positive for your signs. Opposite would be negative, always positive for the last one. Square, multiply, square. And there you go. It does get easier and quicker the more you practice it. These two are a little bit different because there's numbers in front of the first term, but that's okay. It's the same process. It's just that you're going to have a number in front of the first term. So 3x minus 2 is your binomial because the cube root of 27 is 3. Same deal, same, opposite, always positive. So same sign, good, negative, opposite, positive, always positive. Square this whole thing. This is a big thing that people forget, is that they're squaring the whole thing. So you're squaring all of 3x, and you're squaring all of 2, okay? And then you're going to multiply these. So 3x times 2. So I'm just writing it out like this because I want you guys to see that that's what you're doing. You're doing the whole term. And you get 9x squared plus 3x times 2 is 6x, and then plus 4. Okay, cube root this whole thing. Cube root of 64 is 4. If you guys don't know how to get the cube root, I probably should have said this at the beginning. In your calculator, it's math, and you go into the math area, and you'll see a cube root there. Okay, same opposite, always positive for our signs. We do have the same opposite, always positive. Square this whole thing. So the whole 4y squared is 16y squared. It's the whole thing squared. And then 1 all squared is 1, and then 4y times 1 is 4y. And there we go. And that's how you factor perfect cubes. So let's go back to our list over here. And the reason why I wrote this list is because you guys are going to have to, at this point, know when to use these guys. Because it's not going to be, what I'm trying to say is that you're going to look at a factoring problem and you're going to have to decide what type of factoring to use. So when do you use these? Well, no matter what, you should always think of GCF first to see if you can take out a GCF. And once you take out all your GCFs, letters and numbers included, you can move on to the next one. Dots. So what do you need for dots? Dots, you need a binomial with perfect squares. Wow, I can't spell. Perfect. Perfect squares. Perfect. So you need 2 terms. That's for dots. You need 2 terms. I put AM and AC together because this one you need 3 terms, or a trinomial. AM, you need A equal to 1, and AC, A does not equal 1. Technically, you could still do AC for anything with AM. You could actually do AC all the time with all trinomials, but that's when you would use these guys. Okay, grouping has to be 4 terms, 6 or 8 or even, okay? And then sum and difference of cubes has to be another binomial. So cubes. It doesn't matter, it can be plus or minus. This one has to be, remember, subtraction for dots. But the difference between the sum and difference of cubes that we just did in this lesson and dots is that dots need subtraction, whereas the cubes can be either. And with cubes, you need 2 terms, just like dots, and you need them both to be perfect cubes. You have to be able to take the cube root of them. Okay, so I hope this video helped you with this lesson, and I'll see you guys soon. Good luck.